All right, today we're diving deep into a molecule that's right at the heart of how our bodies create energy, how we metabolize, and even the science of aging itself. It's called NAD+, and we're going to get right into it. So, let me ask you something. Do you ever feel like your personal battery just doesn't hold a charge the way it used to? You know, that feeling of fatigue, a little bit of brain fog, or just noticing that you don't bounce back as fast? It's a super common feeling, and trust me, it's not just in your head. It's actually rooted deep down in our biology. And a lot of the time, the story leads right back to this tiny but incredibly mighty molecule, nicotinamide adenine dinucleotide. Let's just call it an NAD+. Think of it as this critical little helper inside every single one of your cells. The big problem? As we get older, our body's natural supply of NAD+ starts to take a nosedive.
And listen, we're not talking about a small dip here. The research is pretty stunning. It shows that by the time we hit middle age, our NAD+ levels can plummet by as much as 50%. That is a massive drop in a resource our cells desperately need. So what's the deal with this molecule?
Now, you might be thinking this is just the latest health trend, but NAD+ is anything but new. Scientists have actually been studying this thing for over 100 years. Its journey from being just a simple find in yeast to a key player in aging research is, well, it's pretty fascinating.
So check this out. It all started way back in 1906 when it was first spotted in yeast. By the 30s, we knew it was involved in basic metabolic reactions. But the real aha moment, the game changer, came in the year 2000. That's when we discovered sirtuins, these special enzymes that need NAD+ to work and are deeply tied to cellular health and how long we live. That discovery really put NAD+ on the map for aging research. Okay, so what is this stuff really? At its core, NAD+ is what we call a coenzyme. Think of it like a manager's indispensable assistant. It's the helper molecule that makes the main enzymes get their job done. And that little plus sign you see? That's key. It means it's in a state where it's looking to grab an electron from another molecule. When it does that, it kicks off a whole chain reaction that helps your cells make energy.
And its job description is huge. I mean, NAD+ is basically the spark plug for creating ATP, which is our cell's main fuel source. It's also required by these enzymes called PARPs. Think of them as your body's frontline DNA repair crew. And it's what flips the switch on those sirtuins we just talked about, which help manage things like inflammation and stress. It is absolutely essential.
So if our NAD+ levels drop as we age, and it's that important for our cells, the obvious question is, what happens if we boost them back up? And this is where the science gets really, really exciting, moving from theory into what this could mean for us in the real world.
In all kinds of studies, bringing NAD+ levels back up has been linked to a whole list of potential benefits. We're talking about fueling our mitochondria for more energy, improving muscle function, and even helping to regulate our sleep-wake cycles for a better night's rest. And in animal studies, it's shown some serious promise for things like boosting memory and learning.
But, you know, one of the most powerful and compelling applications is in the field of addiction recovery. For decades, high-dose IV NAD+ has been used in this space. The idea is that substance abuse puts this incredible strain on the brain, just burning through its NAD+ supply. So by rapidly flooding the system with NAD+, the therapy aims to help repair some of that damage, dial down the intense cravings, and just ease those brutal withdrawal symptoms that make recovery so tough.
And this quote really drives home the potential here. One expert who's treated thousands of patients called it a restorative therapy, not something that just masks symptoms, but something that actually helps to reboot the entire system right down at the cellular level. So all of this naturally leads to the big practical question, right? If you want to raise your NAD+ levels, how in the world do you actually do it? Let's break down the main options.
Well, there's not just one path. And the method you might choose really comes down to a trade-off. You're balancing convenience, cost, and what's called bioavailability, which is just a fancy way of saying how much of the stuff actually makes it into your cells to do its job.
Understanding your options here is key. First up, you've got your oral precursors. Super convenient, way more affordable, but you do lose some of the potency in the digestive system. Next, you can step it up to subcutaneous injections. These bypass your gut, so you get better absorption. This usually means a protocol of small, daily shots. And then you have the big one, IV infusion. This is the most direct-to-cell, most potent method, 100% bioavailability. But it's also the most expensive and time-consuming, sometimes taking hours for a single session.
Now, if you do decide to go the oral route, you're going to see two acronyms pop up all the time, NMN and NR.
They're both just precursors, raw materials your body uses to make NAD+. NMN is a little closer to the finish line in that conversion process. NR is a form of vitamin B3, and some studies have shown it can give a really significant boost to NAD+ levels. The jury's still out on which one is definitively better, but both have research backing them up. Okay, so with all this exciting promise, we gotta pump the brakes for a second and have a necessary dose of reality. It is absolutely vital to weigh the potential rewards against the known risks and things to consider before you even think about jumping in.
So let's just start with the most important question of all. Who should be really cautious, or maybe even avoid this altogether?
Medical guidelines on this are crystal clear. If you're pregnant or breastfeeding, or if you have certain pre-existing conditions like uncontrolled heart problems or severe issues with your kidneys or liver, NAD+ therapy is not for you. Getting a green light from your doctor first is non-negotiable.
Now, for those who do move forward, especially with injections or an IV, there can be some side effects. They're usually mild and they don't last long. We're talking things like a brief headache, feeling a bit flushed, or some nausea. But again, they typically pass very quickly.
And this is a huge point, especially for the oral supplements. You have to remember that this market is not regulated the same way as prescription drugs. That means the purity, the dosage, it can be all over the place from one brand to the next. That lack of oversight means there's a risk factor that you, the consumer, really need to be aware of.
So, after all that, this is where we land. How do you decide if exploring NAD+ is the right move for you? It's all about making a decision that's not just informed, but one where you feel empowered. Really, the big takeaway here is a simple three-step game plan. First, do your own homework. Go look at the actual research and clinical trials. Second, get really clear on what your personal health goals are. What are you trying to achieve? And third, and this is the most important one, go talk to your doctor. Have a real conversation about your health history and see if this even makes sense for you. And that leaves us with the really big question, doesn't it? Is strategically boosting our NAD+ levels a true key to unlocking a healthier, more vital life as we age? Or is it just the latest, most sciencey chapter in our timeless search for the fountain of youth? The research is still coming in, and I guess only time will really tell.